Okay, now we've got another achieved topic, and it's called expanding brackets. Now, whenever you have, you're asked to simplify an expression like this. Expressions, remember, don't have equal signs equal to two expressions. An equation has an equal sign and another expression on the other side of the equal sign. These have no equal sign within two expressions on either side. So these are called expressions, not equations. Whenever you're asked to simplify and the expression has brackets in it, you are trying to remove the brackets, so there are no brackets. So simplifying, in this case, would be expanding the brackets, it's called. So to do that, you can do it. There's several ways we can do this, and I'm going to try and hopefully you'll get a way that works for you. So when I'm multiplying everything on the outside of the bracket is the curly thing there. In programming, they call them parentheses, but we're just going to call them brackets in maths. So I multiply whatever's on the outside by every term in the inside. Remember, terms are separated by operators. So in this case, I've got a plus operator. So I have a term on this side of the operator and a term on this side of the operator. So I've got two terms. I have to multiply the term on the outside by every term inside the brackets to get rid of the brackets to expand it. So I'm going to do it using lines so you can see. If I was writing it out, I would write it out fully. So I'm going to go 3 times A. And if I'm drawing, I'll go like, hang on, let's just use the pen. I go 3 times the first term. That means I've got 3A. 3 times A is the same as 3A. So I'm multiplying 3 times A, and that gives me 3A. And then I've done the first term in the brackets. Now I have to do the second term in the brackets. I want to keep the plus sign. So what is the sign of this number on the outside? Is a plus. If it has no sign, it's automatically a plus. So 3 plus 3 times plus 2 is plus 6. Okay, now I've expanded it because I now have no brackets anymore. Got rid of the brackets, so I've gone 3 times 2, and that gives me the plus 6. Remember, keep the sign there. So plus 3 times plus 2 gives me plus 6. Okay, so that's now expanded. Now, if I wanted to go back from here back to having it back into brackets, that wouldn't be called expanding. That would be called factorizing. And to do that, I'm looking for the highest number multiple that's in 3 and in 6. So the highest sort of factor that is in 3 and in 6. And that's 3, isn't it? So when you're factorizing, you're looking for the highest factor in both. So the highest factor is 3, and the highest factor there is 3. Highest factor in this one is 6, but we can't. There's no 6 in that one. So you've got to get the highest factor out of both of them. You put that on the outside of the brackets, and that's why the 3 is on the outside. And then you've got to multiply. To get 3A, you've got to multiply the 3 times something to get 3A. Well, it's going to be a there, isn't it? And then I'd multiply 3 times something to get 6. So I'd put the 2 there. So if I was going from this back to that, that would be called factorizing by taking the highest common factor. Anyway, just explaining factorizing. Now let's have a look. Let's try this one. So I'll multiply 6 times 2A this time. Now 6 times 2A is just 12A. Okay, cool. That's pretty straightforward. Awesome. And then I've got to multiply 6 times minus 2. So if it's 6 times minus 2, it's going to be a minus 12. Great. There's our answer. That's simplified by expanding the brackets. Now, think about if I was putting the highest common factor on the outside. Could I put the highest common factor on the outside? Yeah, well, I could actually simplify it to this, couldn't I? 12 and 12 is 12. So I could put 12 on the outside. And 12 times something equals 12a. Well, it's just a. And 12 times something equals minus 12. That would just be 1. So notice how when I factorize this one, put it back into brackets, it didn't actually come out with the same as that, because this here isn't fully factorized. That's fully factorized when I'm going from here back to brackets. This is fully factorized. This one here isn't. So sometimes when you fully factorize, you'll get a different answer to that. So this wasn't fully factorized to start with. Anyway, that's a side note. This isn't about factorizing, this is about expanding. But just so you could sort of see the process, if I was finding the greatest factor of 12 and 12, which would be 12. I put that on the outside of the brackets, and then I multiply the outside by the inside first term to get 12a, which means it would be just a. Okay, so fully factorized, sometimes this here, if that's not fully factorized, it would be a different answer. Anyway, let's do the next one. We've got 2a on the outside this time, and we're multiplying it by a. Now, remember the rule. When you're multiplying values, variables, you add indices. So that's a to the power of 1, that's a to the power of 1. So your answer is actually going to be, you add indices, so it's actually going to be 2a, add the indices, and the indices is the power, so there's actually 2 of them, 1 plus 1. So your actual answer is 2a times a is 2a squared. Then I have to multiply that times the next term, so 2a times 1, it just leaves me with what? Just 2a, yeah. 2a, awesome. Can I add them together? No, because remember, they're not like terms. So when we've got this and there's a plus, we go back to our first rule. Can I add these together? No, that's to the power of 2, that's to the power of 1. Can't add them, so we can't simplify that anymore. This is the lowest simplification we can do. That's to the power of 2, that's to the power of 1. Can't add them or subtract them. Okay, let's try this one here. Now this one's a little bit different. There's no number on the outside. So if there's no number, it's got a minus there. How do we simplify if there's no number? Well, there is. If there's a minus there, that means there's a secret 1 in front of it. Next to it. So it's not written. So you just got to go, if you see a minus on the outside, you realize that's actually minus 1, not just minus. So minus 1 times x is what? Minus 1 times x is just minus 1x, or just minus x, because you don't have to write the 1. And then we have to multiply the minus 1 again by times minus 2. So we've got a minus 1 times minus 2. If you do that on the calculator, you'll notice that the minus times a minus changes it from minus to plus. So it turns into a plus. Minus times minus is a plus. So 1 times 2 is 2, plus 2, and not minus 2. Okay, there's a few examples and how you're doing it. You're doing the term on the outside, multiply every term in the inside, so you get rid of the brackets. That's what expanding is. Now you might, later on, you'll get a lot of these at level 1, where you've got 2 brackets together, and these are called quadratics. But anyway, you get 2 of them together like that, and you've got to expand this. Now, we've done everything on this, on the outside has to multiply by every term in the inside. So when we've got 2 things next to brackets, we have to multiply every term by every term in here twice. So let's do this systematically. Let's multiply the first term in there by the first term there. So what is the rule when you're multiplying? X times x. What's the rule? You add the indices. So that's to the power of 1, that's to the power of 1. So that means it's, what is it? It's x squared. Yeah. Cool. I'll just write that. X squared. Yeah. X times x is x squared. So I've done the first one. First term multiplied by the first term. Now I have to do the first term multiplied by the second term. So x times 3 is 3x. X times 3 is 3x. Okay, right. And now, so if that's the same as doing that. But we've got another term on the outside that we have to multiply now. We've got to do the 2. So I'm going to go 2 times x now. So 2 times x is 2x. Because I can't leave it out. I haven't finished yet. And I have to multiply that second term by the second term there. So 2 times 3 gives me 6. Right, now is that our final answer? Okay, we've got rid of both brackets, but it's not our final answer because this is the same as adding or subtracting like terms. Because what are we doing? We've got terms here. How many terms? Let's check how many terms. We've got a term there, a term there, term there, and a term there. So we're back to adding and subtracting like terms. And when we're doing simplifying, we have to come up with the most simple answer. We can't just leave it like that. We've expanded, but now we have to add like terms if we can. We've got to simplify even more. So I've got x to the power of 2. Is there anything else to the power of 2? No. So I can't simplify that, so I'll just write x to the power of 2. Great. Now I've got 3x to the power of 1. So x to the power of 1. Have I got any other x to the power of 1? Yes. That's x to the power of 1 and that's x to the power of 1. So we can go plus 3x and plus 2x equals what? 5x. So yeah, we can add them together. Awesome. So we've simplified using adding like terms. And I've got a plus 6. Is there any other numbers by themselves? No. So I'll just leave the plus 6 on the end because I can't add it to anything else. And so now that is fully simplified. I had to expand the brackets and then I had to add like terms to get it to its full answer. Yeah, and so that's it there. Awesome. That's expanding brackets. I could go into a lot more of these and do a little bit more harder ones, but I think this gives you an idea that I'm multiplying every term in this brackets with every term in this brackets, every term with this brackets with every term. Now if I was doing this, instead of doing it like that, I could have gone x times x and actually written that when I was doing my answer. I could have done this, x times x, like that, and then gone, oh yeah, that is the same as x squared. See, that's where I got x squared from. X times x, that first bracket times that bracket, x times x. Could have written it like that, but I skipped that step. I just went straight to x times x equals x squared. Then I could have gone x times 3. So I would have gone plus x times 3. Instead of doing this step here, I just skipped it and I went straight to 3x. So I just went straight to x times 3 is 3x. Okay. See, notice how I skipped entire. I went straight to that because I knew x times x is x squared and x times 3 is 3x. So if I was doing 2 times x, I would write the same. I'd go, yep, we've got 2 times x times x, and that gives us, it's the same as 3 times x, isn't it? Sorry, x, not 3. 2 times x is 2x, so I'd add the 2x. So I actually did skip one step. I went 2 times x is 2x, and I just wrote 2x instead of 2 times x. So you don't usually have to do this step here. You can just multiply 2 times x knowing it's 2x. And then 2 times 3, I could write 2 times 3 like I did on the end. But I know 2 times 3 is 6. So I just wrote, jumped straight to plus 6 there. So hopefully you realize I was just multiplying x times x, x times 3, 2 times x, 2 times 3, and skipped, went straight to that and then simplified it. Or you could do the very long way of doing it like that, but that's sort of, really, you don't have to do that step. You can actually sort of miss that out if you understand x times x is 2x. Yeah. All right, anyway, hopefully, I really hope, I'm just trying to clarify that, because some teachers will teach it in multiple steps like that, just to make it real clear. But in a test, writing it like that is perfectly fine, and then simplifying it, so you've got your simplest answer, where it's you've added like terms or subtracted like terms, so you've got your simplest answer. That's more correct. And that is that topic, which is expanding brackets. And hopefully you are now a master of expanding brackets, whether they're double brackets or just a single brackets like that. You can do any of them. And I'm hoping you'll be able to do that in your test.